Tan tan ta 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 tan bong bong tan 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 bong bong tarara ra 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 ra.
The
Lax.
Squad!
Hi! 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 Oh my gosh. Welcome back to another video of the Galaxy Squad! Today, we're going to help a ship to reach its destination. We're going to determine how vectors can represent distances and directions. To demonstrate how to use vectors to understand directions, distances, and times associated with movement and speed. And now for the materials, we need 3 pieces vector Voyage map and red, blue, and green ball pens or pencils.
The ship can sail 8 square units per month, starting from Spain, traveling west or bearing 270. Now, we are going to show you where country it will land and how many months it will take to reach land with the help of Vector Voyage.
Good morning, Galaxy Squad, and for today we are back for another video. And for today as well, I will be your demonstrator on how to get the Vector Voyage location using the Vector Voyage worksheet. Stay tuned!
For the first part of our voyage, as you can see, it started at Spain. It has a direction follows. Every 8 blocks is equivalent to 1 month. Therefore, our journey took 1, 2, 3, 4, and an extra 3 blocks, which in that case is equivalent to 0.375 extra months. Overall, the amount of months it took from Spain to USA is 4.375 months.
Unfortunately, the wind does not always blow the way you want. To determine how the wind affects our travel, let's include the wind vector.
For the second part of our vector voyage, we will be taking a look at the possible wind vectors. The wind vectors will be represented by the blue lines you can see in the vector voyage sheet. Here are the examples. At the first month of our traveling, we find out a wind vector is going down south, changing the direction of our ship. At the second month, another wind vector is located, this time going southeast. At the third month of our traveling, another wind vector is located, but this time going west. At the fourth month, another wind vector is located, this time going up north. And that's our last wind vector. As you can see, wind vector occurs every month. Overall, the amount of travel we got with the wind vector took us 5.25 months.
Unfortunately, ocean currents affects both too. Each month, you must also add a current correction vector to find your actual final position.
This part of our vector voyage, we'll be taking a look at the ocean currents. They are marked by a green pen, as you can see on the worksheet. They also occur every month. Now let's check them out. The first ocean current occurs at the first month, and it's heading down south, once again changing the direction of our ship. The second ocean current is found heading down west. The third one is going down southwest. And that's our final ocean current. Overall, together with the ocean currents, the final part took us 4.625 months, but no landfall. The conclusion of our vector voyage: for the first part, it took us 4.375 months and it landed at the United States of America. For our second part of our vector voyage with the wind vector, it took us 5.25 months, once again landing at the United States of America. And the last part, it took us 4.625 months with the wind vector and the ocean currents, but with no landfall. Thank you so much.
This video is under the lesson of vectors and scalars. Now, what are vectors and what are scalars? Scalars are quantities that do not need to be defined by a direction and are sufficiently described by magnitude. Time, mass, temperature, distance, speed, and energy are examples of scalar quantities. Vector quantities are measurements that have a magnitude, a unit, and a direction. Some examples of vector quantities are velocity, acceleration, force, momentum, and electric field. Adding vector is more complex because we need to consider the magnitude and the direction as well. Adding vectors can be done using two methods, graphical and analytical. The sum obtained from adding vectors is called the resultant. It represents the resulting magnitude and direction of the combined vector quantities. In the graphical method, also called as polygon method or head-to-toe method, the vectors are connected until the resultant vector is determined. This method is helpful if you are adding two vectors. One of the methods in finding the resultant vector is using the graphical method. You must observe carefulness and accuracy while using this method. Similarly, living a good life requires prudence and a clear goal in life. To understand vectors better, you must review some trigonometric concepts, as well as the concept of Pythagorean theorem, with the formula of a squared plus b squared is equals to c squared. Pythagorean theorem is a useful method of determining the result of adding two and only two vectors that make a right angle to each other. The method is not applicable for adding more than two vectors or for adding vectors that are not 90 degrees to each other.
Concept check question number 1. The statement goes, when calculating the sum of vectors a and b, a plus b, we put the tail b at the tip of a. What would be the effect of reversing this order into b plus a? Personally, in my opinion, there will be no such big difference because it's addition, and so it doesn't matter what kind of order you're doing, the answer would still be the same. Just like adding 2 plus 1 to 1 plus 2, the answer will still be 3 because addition is irreversible. Even if you started it from that end or in that end, the answer would still be the same. Same goes with the vector. It doesn't matter if we started from the top or to the low because the answer will still be the same. Hey guys, now for the second part of the concept check, we will be answering the question, what is the magnitude of the vector with these components? X is equals to 3 meter per second and y is equals to 4 meter per second. First step, make a Cartesian plane. Second step, add the coordinates. Y is equals to 4, boom, and x is equals to 3. Then, locate and connect it to the origin, just like this one. Now, we'll be finding the magnitude using Pythagorean theorem. formula for Pythagorean theorem is a squared plus b squared is equals to c squared. Next step, substitute. A is always equals to x and b is always equals to y. Since the value of our x-axis is 3, then this will be 3 squared. Since the value of our y-axis is 4, this will be 4 squared is equals to c squared. Then substitute 9 plus 16 equals to c squared. Add the two numbers, we can get 25 is equals to c squared. In order to cancel the squared, simply square both sides. Boom, boom, 5 is equals to c. The final answer is 5 meter per second. After obtaining the value of c, we will now proceed in getting the value of the degree. In order to get the degree, all we have to do is the following. First, get the tangent of x and y. Tangent theta is equals to x over y. X, as we all know, is 3 and y is 4. Next step, 3 divided by 4 is 0.75. That is the value of our theta. Now, moving on, we have to get the inverse tan of 0.75. In order to do that, click Shift, tan, 0.75, and we get 36.8699. Once again, in order to get this, all you have to do is inverse tan or shift tan 0.75. Now, in order to get the degree of 36.8699, just press the degree button right there. Now, our final degree is 36 degrees, 52 minutes, and 11.63 seconds. Combine your answers with the value of c, which is equivalent to 5 meter per second, plus the degree 36 degrees, 52 minutes, 11.63 seconds, and that is the final answer of concept check number 2. We're gonna locate the direction. Locating the direction is very simple. Just go back to the Cartesian plane, right here. Just see where in the Cartesian plane your triangle is located. As you can see, it is in east and in its north. Adding them together, it's northeast. So go back here. In your final answer, remember to add the direction, which is in that case northeast.
So here in Explore Your Surroundings, we will identify each of the following quantities as either a scalar or a vector quantity. We will write S if it is a scalar quantity, and we will write V if it is a vector quantity on the space provided. First one is the amount of a sugar. Amount of a sugar only has a mass, so it is a scalar quantity. Next one is torque. Torque is inherently a vector quantity because part of the torque calculation is determination of direction. Next one is a speed of a tricycle. The standard tricycle can go up to 11 miles per hour, while the ultra can go up to 56.5 miles per hour. So, speed of a tricycle is a scalar quantity because it doesn't have a direction. It only has its speed and time. Next one is the potential energy. Potential energy is a scalar quantity because it only has a magnitude but no direction.
Next one is the acceleration. Acceleration is a vector quantity because one of the examples here in vectors quantity is acceleration. Therefore, it is a vector quantity. Next one is the work done. Same with the potential energy, it only has a magnitude but no direction. Therefore, it is a scalar quantity. Next one is the wavelength of a sound traveling in a vacuum. It is a scalar quantity because it does have a magnitude but it doesn't have a direction. Next one is the electric field. Electric field is a vector quantity because first, it is one of the examples here in the vectors, electric field, and it does have a magnitude and a direction. Next is the luminosity of a candle. Same with the wavelength of a sound traveling in a vacuum, it has a magnitude but no direction. Lastly, the displacement. Same with the electric field, displacement has a magnitude and a direction. That's all. Thank you.
The sudden change of direction or route of travel will often delay the landfall, causing the traveling to become much longer because of the natural event that may occur along the way, such as change of wind direction and ocean currents.
It's a great way of measuring directions, locations, or coordinates of something or someone based on the information given.
There's a lot of motivation for me to become the best version of myself. The hard work of my parents, the support of my family, friend, and classmates, and loved ones give me the courage. I am not here without them. Two of them are difficult. If you are not listening to the teacher or someone who teaches you, in order to overcome the difficulties, you need to listen carefully and always remember that everything is easy if you want to learn.
For our first part, our journey started at Spain.
The hard work of my parents, the support of my family, friend,